Namaste Coders. I hope you are fine, doing well in your life. So today we are going to solve problem of the day for 12th February. The question is max sum of a pair with equal sum of digits. Okay, so fine, topics are array, hash table, sorting, heap map. Okay, so you are given a 0 indexed array nums consisting of positive integers. You can choose two indices I and j such that I is not equals to j and the sum of the digit of the numbers nums I is equals to that of nums j. Return the maximum value of num I plus nums j that you can obtain all possible indices I or j. Okay, fine. So let me explain you the problem. So this is given, right? So I always suggest you that you should first focus on the details of the problem. So what is given, what all things are given, what are the details, and what is expected, right, from this solution. So this is given. What are the details? We have to find two indices I and j such that I is not equals to j, of course. So we can use two pointers, and num I is equals to num j. Okay, no, so sum of digit of num I is equals to sum of digit of num j, and we have to return the maximum value of num I plus num j. Okay, so what we have to do, we have to find two numbers whose sum of the digit is equal. So like 18 has some digit 9 and 36 also has some digit 9, and then we have to return the maximum value of such numbers, right? So 18 plus 36 is equals to 54. So the answer is 54 here. So let me just run it how to. So this is the question, right? So here 18 has some digit 9, so, and 43 has some digit 7. Okay, now 36 also has some digit 9. So 36 plus 18 has 54. We have 54. So we have 9. We have 54 against 9. We have 7. So we have 43 against 7. 13 means 4. So we have 13 against 4 now. And 7. So 7. So 43 plus 7 means 50. So we have 50 against 7. And this has should be plus x, but x is not there. So this is minus 1. Because we don't have any number against 4, because we need two numbers, and there are no two numbers whose sum is 4. So we have to return maximum value, so which is 54, right? So this is what we need to do. And how to solve this? So as I have tried the dry run, we can see that we have to use hash map, right? Hash table. So this is obvious. So this is the obvious approach. So native approach, or I can say obvious approach. Obvious approach. I am giving the name obvious approach using hash table. Then we will think that we can, if we can, what I can say, if we can optimize it better or not. So what can do? Make a hash map. Make a hash map of some digits. Hash map having key as having some digits as key and digits as value. Not digit but numbers as value, right? So we will make a map. So let's make it. So we have key as 9, and we have 18 comma 36 against it. We have key as 7, some digit at 7. We have 43 which has some digit 7, and we have 7 which has some digit 7, and we have 4 right here, and against 4 we have value 13, right? So we are making this map, right? First of all, so this is the first step. Then second step, take top two elements from each key value pair and use and take a sum of them and update to max sum if okay, not if, right? So what we will do, we'll do top two elements, right? If there are like multiple elements out there, like there is 9 also, there is 27 also, so we'll update this like 9 into 27, we'll store them, and we have like, let's see, we have 16 here, so let's add 16 also. Okay, so what we'll do, we will do top two elements, right? So top two means the most valued two elements, so 36 and 27 we can use here. So for that we can use a priority queue also, right? We can maintain a priority queue. So yeah, for this thing we can use priority queue, so that will be done in O1 time complexity, because for this we have to take O(n) time complexity, right? For iterating through this 2 times, we will take O(n) time complexity, so we will reduce it to O1 time complexity, so we can use priority queue for that. So that's, as you can see how we are optimizing our native approach to the optimized approach, right? So now we will do, and we will take the sum, right? So the 9 has sum 36 plus 27, so let's say this is not 27 but this is anything like 9 only, because we don't need to change our answer, right? So 9 have 18 plus 36, which is 54, right? 7 has 14 plus 16, 43 plus 16, which is 59. Okay, but okay, not 16, let's say 7 again. Okay, anyways, so 43 plus 7, which is 50. I don't want to change the original answer, and 4 have nothing, -1, right? Because there is only one element there. So we'll choose the maximum number out there. So maximum number from these are 54, so we'll return 54. So this is our native approach to optimize this, right? To optimize this iteration, what we can do, first thing we can use hash, right? So for optimizing this this second wala approach, what we can do, we can use hash map. So what hash map will do, hash map will always store maximum 2 elements, right? 2 maximum elements, and then we will use those 2 elements in O1 time complexity. So that can be done using hash map. One another thing is for elementing this, right? We have to find the maximum here, so this will also take O(n) time complexity. So they are extra time complexities, right? So what we can do, we can only store the maximum element here, right? So let's let's take a dry run again in the what I'm thinking. So I'm thinking another approach. So let's make a dry run here, right? What I will do, I will make a map which stores the maximum value, which store the maximum value of the sum digit having 9, right? So currently it stores 9, 18. Then we will iterate over 43, so it has the 7, so 7 has 43. Then we will have 36, right? So what it will do, it will add 36 with this first, right? So we have our answer is equals to 0. If we found something like we have 36 and we have already stored some element in 9, right? So what it will do, it will add 36 with the 18, right? So 36 plus 18 has 54, so it will update 54, and then it will replace 18 with 36, because 36 is greater than 18, right? Then we have 13 means 4, so there is nothing in 4, so we will store 4 as 13. We will not update it because there is no previous element in 4, so this is the first element, that's why we will not consider it for the answer, right? Then we will have 7, so we have an element in the 7, so we will make a sum is 50, which is lesser than 54, so that's why we will not update current answer. and sum is also lesser than 43, so that's why we'll not update this 43 also, right? Then we have 9. We have element in 9, so 36 plus 9 is 45, so we will not update answer because 45 is smaller than 54. And again we will not update our 9 because our value of against 9, because 9 is again smaller than 36. Then we have 16. 16 means 7, so we will same here. But yeah, we have a element against 43. We have a element against we have a element against 7, so the sum of 16 is 7. So we have an element against 7, so we will take a sum. Sum is 59, right, which is greater than the current answer, so we will update 59, but we will not update this 7 because 16 is smaller than 43. So what we will do, rules, right? If there is no, so we'll write these steps. First, iterate 3HROU through nums with nums, so we will use I for that, right? Second, x take a digit sum of I, so we'll use x for that. So third, check if x has a value in map, right? So if yes, if no, update map with x as value y, x as value I, right? Because, and we will not update answer here, right? Because there is no other value for the current sum, right? So else, if no, else what we'll do, take a sum equals to x, so map x plus I, okay, update answer and update map x. So if I is greater than map x, so we will update map x, and if this sum is greater than answer, then we will update answer. So this is all we need to do. So let's code it. Let's write the code. I hope you understand this problem, this solution. That's all. That's what I have always suggest you, that first focus on the details, what is given, what is required, and what are the other details. You can also consider the constraints for checking the required time complexity. Then we will go through the native approach, and while writing the native approach, we will try to optimize the steps, right? So that's what we are doing. We have first discussed the details here, then we will write down the native approach in a very detailed manner. And while writing the native approach, I have thought of a particular things that can optimize these steps. So I have optimized this step, I have optimized this step also. That's how we will reach this solution in which can solve the problem in just one iteration, right? The space complexity is again n, so this will take 2-3 iterations, and this will also take a lot of space, extra space, like this, right? So that is a space complexity of n square, and the time complexity will be like something multiple n's, right? So which will be considered as O(n), but still this will be done in one iteration. So let's write the code. First we have to make a map. MP is nothing but a map for I in nums, right? We try iterate I, x is some digit I. So let's make a some digit I, answer equals to 0, I greater than 0, answer. Yeah, so I percentile 10, I percentile 10 equals to I by 10. I think this will work. Yeah, so then so take a digit, check if x has value in map. So if x in map, so if x not in map, right? If x not in map, update x, right? So we map mp x equals to I. So else if x is there, so take a sum is map x mp x plus I, right? Update answer. So if answer equals to max sum answer, update map x. So mp x equals to max mp x comma I, right? So this is all we need to do. We'll return answer. So answer is nothing but is 0 in the start, and we will return answer, not 0 but -1, right? Because if there is no such cases, we have to return -1. So that's all we need to do. This is answer. So this is giving 24, right? So I think this is, so why 24? Because answer is sum. So if x not in mp, let's print answer, print I comma answer. Let's see if it is giving anything wrong. So 10 means answer is 10. 12, what is this? Why it is 0? I 0. Okay, I 0 nahi. Print I here, print I, print answer here, because I is getting reduced now. So for 10 answer is 10. For 12 answer is 8 for 19. So this is wrong, we have to find the answer in a correct way. I percentile 10, this is and 10, sorry, I percentile 10, my mistake, guys. And I have done a bitwise operation, which is so yeah, this is getting passed. Let's submit this. So yeah, this is solved. We have solved this problem well. Analyze the time complexity. So we have done in the O and time complexity. So let's see the better approaches. So this is just find the digit. So as you can see, they are also doing the same thing. They are just making the initial list and all those things. That's why they are doing in a fewer millisecond, right? Doesn't matter, because this is all we have to do, right? So yeah, that's all for this solution. I hope you understand this problem well. So thank you for your time. Thank you for watching this video. If you find this video this helpful, you can share your thoughts in the comment section. Also, so this video is a part of a daily LeetCode problem series which I have started 30 days or 34 days before. So you can go through those videos, you can check those videos. I have created a playlist. I have shared the link in the description box. Along with this, I am also solving the problems from LeetCode 75. So we have already solved all the first problems from every topic. So like first problem from array, two pointers, and all other topics till here. We will start with the second problem now. We will solve second problem from every topic. Like I will upload 1 or 2 videos every day for these LeetCode 75 along with this daily problem. So if you are interested in DSA or problem solving, Python, C++, anything, you can follow me, you can subscribe me, you can ask your friends to do that. Along with this, I have also created a WhatsApp channel, and the link is given in the description box. If you are interested in building a community, so you can join that channel. That will be helpful in network building, most importantly. Secondly, we can discuss various things there. Like if you have any doubt, you can ask me directly in the WhatsApp. Other than that, we can also start some good projects for our resume. So that is also a very important thing we can do in using our community. We can discuss multiple things there, right? So if you are interested, you can join that. So thank you for your time. Thank you.